Fire is one of the most destructive hazards affecting both lives and properties. In the Philippines, fire incidents are often caused by faulty wirings, flammable materials, and delayed emergency response. Traditional fire alarm systems mainly rely on local alerts such as buzzers or sirens. However, these systems become ineffective when no one is present to hear them, allowing fires to escalate rapidly and cause severe damage.
Because of this limitation, there is a growing need for a smarter and more responsive fire detection system, one that can detect fire early and notify users immediately even from remote locations. To address this problem, we present FireGuard, a smart, real-time GSM fire alert system designed to improve early detection and provide both local and remote alerts for faster response and improved safety.
The FireGuard system is designed to address the limitations of traditional fire alarms by integrating microphone tower technology, GSM communications, and multiple sensors into a single intelligent system.
At the core of this system is the Arduino Uno, which functions as the brain. It continuously gathers data from different sensors, processes the information, and makes decisions based on program conditions. What makes this system innovative is its ability to analyze multiple environmental factors instead of relying on a single indicator. This is achieved through its multi-sensor detection capability, which improves accuracy and reliability. Now, let us look at the key detection features of the system. Flame detection. The system uses a flame sensor to detect infrared radiation emitted by fire, allowing immediate identification of actual flames. Smoke or gas detection. The MQ2 sensor detects smokes and combustible gases, enabling early warning even before visible flames appear. Temperature monitoring. The DHT22 sensor monitors heat levels, helping identify abnormal environmental conditions that may indicate a developing fire. This multi-sensor approach reduces false alarms and ensures more accurate detection. In addition to detection, the system also focuses on effective communication through the GSM module. It sends SMS alerts to inform users of detected hazards. It initiates phone calls to ensure immediate attention.
This allows the system to notify users even when they are far from a location, improving response time during emergencies. Overall, by combining sensing, processing, and communication, the FireGuard becomes a smart, automated, and reliable fire detection solution.
Now that we have discussed how the system works conceptually, let us take a closer look at the hardware components that make the FireGuard system functional. Each component plays a specific role in the overall operation of the system. These components work together to perform three main tasks. First, detecting environmental conditions, processing data, and triggering alerts. By integrating these modules, the system is able to monitor its surroundings continuously and respond immediately when a potential fire hazard is detected.
Now, let us discuss each component and its function. First, the Arduino Uno. It acts as the central controller, processing all sensor inputs and executing commands based on programmed logic. Next, the KY026 flame sensor. It detects infrared radiation emitted by flames, allowing immediate identification of fire presence. Next, the MQ2 smoke sensor. It detects smoke and combustible gases, enabling early detection even before visible flames appear. Next, the DHT22 temperature sensor. It monitors temperature changes to identify abnormal heat conditions that may indicate a developing fire. Next is the SIM900A GSM module. It sends SMS alerts and initiates phone calls, allowing remote notifications of detected hazards. Next, the active piezo buzzer. It provides an immediate audible alarm to alert individuals within the vicinity. Lastly, the power supply and jumper wires. They ensure stable power distribution and proper electrical connections among all components. All these components work together in a continuous cycle of monitoring, processing, and alerting, making the system efficient, reliable, and responsive to fire hazards.
Now that we have discussed the hardware components, let us examine the software aspect of the system, which controls how all components interact. The program begins by including two essential libraries. Software serial. This allows the Arduino to communicate with the GSM module using digital pins, since it only has one hardware serial port. DHT library. This handles communication with the DHT22 sensor and allows accurate temperature readings. The code then defines the pin assignments and variables, which establish how each component is connected and controlled. Each component is assigned a specific pin. Flame sensor for digital input, MQ2 sensor for analog input, DHT22 for temperature data, buzzer as digital output, GSM module through software serial pins. It also sets threshold values that serve as the basis for detecting hazardous conditions. A temperature threshold of 50 degrees Celsius, a smoke threshold based on the analog readings. The program is structured in two main functions. First, the setup function. The setup function runs once at the start. It configures input and output pins, starts serial communication for both GSM and monitoring, initializes the temperature sensor. This ensures that all components are properly prepared before operation.
The loop function runs continuously and performs three key tasks. First, sensor reading. The system reads flame presence using digital input, smoke levels using analog input, and temperature using the DHT22 sensor. Second, condition evaluation. The system checks if a flame is detected, smoke exceeds the threshold, and temperature exceeds 50 degrees Celsius. These conditions are converted into Boolean values and evaluated using an if statement. Lastly, response activation. If any hazard is detected, the buzzer is activated for local alert, the system sends an SMS alert, and then initiates a phone call. This ensures both immediate and remote notification. A key feature in the code is the alert sent variable. It prevents repeated alerts for the same event and ensures that SMS and calls are only triggered once per detection. When the environment returns to normal, the buzzer is turned off, the alert flag is reset, the system resumes monitoring. This creates a self-resetting and continuous monitoring system. Additionally, the code uses data types such as int, float, and bool. Conditional statements for decision-making, functions like send SMS and make call for modular programming. A short delay is also included to stabilize readings and avoid excessive processing. Overall, the code enables continuous monitoring, intelligent detection, and automatic response, making the system efficient and reliable.
This project demonstrates how modern technology can enhance fire safety by integrating multi-sensor detection, microcontroller processing, and GSM communication.
The system provides first, accurate detection through multiple sensors. Second, immediate local alerts through a buzzer. And third, remote notifications through SMS and phone calls. These features improve response time and increase safety, especially in unattended environments.
Although the system has some limitations such as dependence on power supply and GSM network availability, it provides a strong foundation for future efforts.
Possible enhancements include first, battery backup systems, second, IoT or Wi-Fi integration, and third, AI-based detection for improved accuracy.
Overall, FireGuard proves that simple and cost-effective technology can be developed with a smart and reliable fire safety solution. Together, let's make safety smarter.